Before Caterpillar's engineers built a wheel scraper so massive it needed two engines just to move, physics drew a hard line at 30 cubic yards, single engines stalled, projects bogged down, and whole mining operations paid the price. But in 1962, one radical idea changed heavy earth moving forever. This twin-powered Leviathan wasn't a triumph of ambition, it was a last resort forced by the limits of traction, weight, and power. How did impossible loads, six-figure machines, and relentless economic pressure create one of the world's most extreme earth movers? The answer reveals the true cost and genius of pushing machinery to its final frontier. At the heart of every earth-moving project lies a basic question: how much dirt can you move, and how fast? For decades, the answer depended on the limits of rubber, steel, and diesel. A single-engine wheel scraper works by driving a sharp blade into the ground, scooping earth into a bowl, then hauling it away. But as bowl sizes climbed past 30 cubic yards, engineers ran headlong into the laws of physics. The force required to cut and load dense soil, known as draft force, skyrockets with each extra yard. Loading 30 cubic yards of hard-packed clay can demand more than 100,000 pounds of pull at the cutting edge. That is more than the torque a single diesel engine, even a massive Cat C18, can deliver to the wheels without spinning out or stalling. Tires become the next bottleneck. As machine weight climbs, so does ground pressure. The contact patch, the area where rubber meets earth, can only transmit so much force before it begins to slip or sink. Push a single-engine scraper too far, and the wheels lose grip long before the engine runs out of power. Even the biggest available tires cannot overcome the physics of traction. On soft ground, the load simply overwhelms the tread, and the scraper grinds to a halt. This hard ceiling is not just theoretical. Field tests and real-world job sites proved that scrapers beyond 30 cubic yards stalled during loading, especially in rocky or clay-heavy soils. More power alone was not the answer. Without enough tire grip, extra horsepower only spun the wheels. The result? A wall that no amount of brute force could break. The industry needed a new approach, not just a bigger engine. In 1962, Caterpillar introduced a machine that broke with every convention in earth moving. The 657A rolled out of Peoria carrying not just one, but two diesel engines, one in the tractor, another in the scraper. This was no marketing gimmick. The design was born from necessity, as engineers faced a problem that brute force alone couldn't solve. Previous attempts to scale up single-engine scrapers had run aground. Even the largest engines available at the time couldn't generate enough tractive effort to load massive bowls without outside help. Push tractors were common on big jobs, but they added cost, complexity, and required flawless teamwork between operators. Every extra machine on site meant more fuel burned, more labor hours, and more chances for something to go wrong. The 657A's dual-engine solution changed the equation. By splitting the workload between the front and rear axles, Caterpillar created a self-loading scraper that could muscle through dense soils and rocky ground without waiting for a dozer. The front engine powered the tractor's wheels, while the rear engine drove the scraper's axle, delivering coordinated force directly to the ground. This push-pull arrangement turned a two-man job into a one-machine operation, streamlining earth moving on a scale the industry hadn't seen before. The debut of the 657A wasn't just a new model launch. It was a statement that the old rules no longer applied. From that point forward, the path was set for a new generation of machines built not just to haul dirt, but to challenge the very limits of what wheels, steel, and diesel could accomplish together. The Caterpillar 657G is a study in raw mechanical force, built to do what no single-engine scraper could. At its core, two separate Cat diesel engines, one C18 up front, one in the rear, work in concert to push and pull nearly 200,000 pounds of machine and earth. Each engine delivers its power through its own transmission. The front engine drives the tractor's wheels, the rear engine powers the scraper's axle. When the operator drops the bowl and bites into packed ground, both engines roar to life, sending a combined 1,128 horsepower to all 8 wheels. The front pulls, the rear pushes, and the result is a self-loading behemoth that can cut, fill, and haul in a single seamless cycle. The numbers tell the story. The 657G's bowl holds up to 44 cubic yards heaped, enough to bury 3 full-size pickup trucks in one pass. Fully loaded, the machine tips the scales at nearly 200,000 pounds, almost 3 times the weight of a main battle tank. On a flat haul road, it can hit 34 miles per hour, loaded or empty, making it the fastest way to move massive volumes of earth over short distances. Operators describe the experience as managing 2 machines at once. Each engine has its own throttle, its own transmission, and its own set of gauges. During the hardest cuts, the machine's hydraulic system delivers over 120,000 pounds of penetration force, enough to shear through hard clay or weathered rock. The 12-foot wide cutting edge slices a path that smaller scrapers simply cannot match. Where single-engine machines bog down, the 657G powers through, making self-loading possible even in the worst conditions. Physics set the limits, and this machine answers with brute coordination. A new Caterpillar 657G rolls off the dealer lot with a price tag that can top $3 million, but for the right job, every dollar makes sense. In large-scale mining or infrastructure work, the real cost isn't just the machine, it's the dirt moved per hour, the fuel burned, and the skill behind the controls. At full throttle, both engines together can drain 40 gallons of diesel every hour. That sounds steep, but in the hands of a skilled operator, the 657G can shift between 1,000 and 1,400 cubic yards in the same time. One cycle from a 657G equals nearly 3 dump truck loads, but needs only 1 operator and no supporting push dozer. For contractors, that means fewer machines, fewer people on the payroll, and less downtime waiting for backup. But the economics only work if the person in the cab knows the machine inside and out. Mastering the 657 isn't a matter of hopping in and pushing levers. Operators spend months learning to coordinate 2 throttles, 2 transmissions, and a hydraulic system capable of generating more than 100,000 pounds of draft force. Training programs at major mining sites often require between 150 and 300 supervised hours before an operator is cleared to run solo. During a typical shift, the operator faces decisions that affect not just productivity, but safety. Cutting too deep or misjudging a slope can tip the balance from profit to disaster. Experienced 657 operators become some of the highest paid hands on a job site, valued not just for their output, but for their judgment under pressure. In the copper mines of Arizona, fleets of 657Gs carve haul roads across open pit benches, moving overburden at a pace no other scraper can match. In Chile, these machines work at high altitude, shifting rock and soil for some of the world's largest copper producers. Coal mines in Wyoming rely on them for reclamation, reshaping the land after the last seam is pulled. On massive highway projects, a single 657G can cut, load, and spread material across a mile-long stretch, replacing whole teams of trucks and loaders. Dam embankments and airport runways demand precision and volume, and here too, the 657G dominates. Its 12-foot wide cut and high-speed cycles turning months of work into weeks. Wherever Earth must be moved at scale, the 657G's dual engines and massive bowl deliver results that smaller machines simply can't approach. No manufacturer has ever built a wheel tractor scraper larger than the 657G, and the reason is simple: the laws of physics won't allow it. Tires capable of carrying more than 66,000 pounds each don't exist, and pushing ground pressure any higher would leave even the toughest machine stranded in soft soil. With a transport width of 14 feet, the 657G already demands special permits and escort vehicles just to move between sites. Anything wider would be too unwieldy for roads or shipping. While Caterpillar's rivals have stepped away from the big scraper market, attention is turned toward technology. The latest 657s come equipped with GPS-grade control and telematics for remote monitoring. Engineers are exploring hydrogen fuel cells and autonomous operation, but for now, no alternative matches the raw, distributed power of twin diesels. The 657G stands as the practical limit, an answer shaped as much by physics as by engineering ambition. Right now, every ton moved by a 657 shapes the world's biggest projects and the boundaries of engineering itself. As infrastructure demands keep growing, machines like this force us to confront the limits of power, scale, and ingenuity. Progress, it turns out, still runs on diesel and daring.